Hello and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring the transformation of absolute value functions. So remember our parent function for our absolute value function is f of x equals the absolute value of x. It makes a V-shaped graph with a vertex at 0, 0. Now this function can be transformed just like all functions by adding constants to our function. So let's just review what each letter in our transformation rule controls. So the A and the D both control the vertical transformations. So A will cause a vertical stretch for A is greater than 1, and a vertical compression when A is between 0 and 1. All right? Now, the D will shift the function up or down. So both A and D affect the y values of the graph. All right. Now B and C, those affect the x values of your graph. All right. So B will horizontally stretch or compress the graph. And then C will shift the function right or left. Okay. Now, let's look at some examples. So each of the following represents a transformation of the absolute value parent function. Describe the transformations and then sketch. So in this problem, our A value is -2, our C value is +5, and our D value is +3. So this negative means the graph will open down. So it's a reflection across the x-axis. In other words, the V shape will open downward. The 2 means your graph will vertically stretch by a factor of, and I'm going to abbreviate that B dot F dot O, by a factor of 2. The x minus 5, that will move your graph right 5, and the +3 will move your function up 3. So now we're going to transform the parent function with these function rules. So the parent function started at 0, 0, but this graph is going to move to the right 5 and up 3. So let's do that. 1, 2, 3, 4, 5. 1, 2, 3. All right. So our new vertex, instead of being at 0, 0, is going to be right here at 5, 3. All right. Now we're going to use our A value to draw in the branches of our V-shaped graph. Now, because the A value is negative, from the vertex, I want you to move your pencil down 2 and write 1. Do that one more time. Down 2, write 1. So now you've got the right side, the right branch of your absolute value function. Now go back to your vertex, right into the middle. This time, I want you to move down 2 and left 1. So 1, 2, left 1. Down 2 and left 1. Now what we're going to do is we're going to connect these points in a V shape. Try to get this as straight as I can. All right. So there's our transformation. It's vertically stretched, reflected, moved right 5 and up 3. All right, problem B. In problem B, the value of A is 3. Now, that's bigger than 1, so that's going to be a vertical stretch. The value of C is -1. Remember, we do the opposite of what's in the brackets. And then the value of D is -6. So because our A value is +3, that's going to vertically stretch the graph by a factor of 3. Because C is -1, it's going to move our graph left 1. And then because D is -6, it's going to move down 6. All right, so remember, our parent function started at 0, 0. But this graph is moving left 1, so go left 1, and down 6. 1, 2, 3, 4, 5, 6. So my new vertex is going to be at -1, -6. Now, once you have the vertex on coordinate plane, you're ready to draw your branches. And to draw your branches, you look at the value of A. The value of A is +3. So from your vertex, you'll move up 3, right 1. So 1, 2, 3, right 1. Do that one more time. 1, 2, 3, right 1. So now we've got the branch on the right side done. Now we need to put a branch on the left side. So go back to the vertex. This time go up 3 and left 1. 1, 2, 3, left 1. 1, 2, 3, left 1. All right, now we'll draw our branches. Got a branch on the right, and we've got a branch on the left. All right, pause the video and try problem C on your own. When you're ready to check your answer, press play. All right, welcome back. So in this problem, our A value is 2/3, our C value is -1, and our D value is -3. So because A is between 0 and 1, this graph will vertically compress by a factor of 2/3. It'll move left 1 and down 3. All right, so again, our parent graph started at 0, 0. But this transformation rule says we're going to move to the left 1 and down 3. So let me put that dot. There's where your new vertex is going to be. All right, now we're going to draw our branches. To draw our branches, we use the value of A, which is 2/3. So that means go up 2, 1, 2, 3. Whoops, I need my pen here. Up 2, 1, 2, 3. Let's see if I can do that one more time. Up 2, 1, 2, 3. No, I would go off, okay? So let's get the left branch, go back to your vertex, and go up 2, left 3. Okay? So notice this graph is wider. That's because it's a vertical compression. A vertical compression. All right, problem D. We have f of x equals -1 times the absolute value of x plus 2. So our A value is -1, our C value is 0, and our D value is 2. So in this graph, we're going to reflect, because of the negative, across the x-axis, and we're going to move up 2. All right, so remember the parent function starts at 0, 0, but this graph is moving up 2. So 1, 2. So our new vertex will be right there at 0, 2. Now we're going to use our A value to draw our branches. So our A value is -1. So you're going to move your pencil down one, right one, down one, right one. Now I could go the opposite way. Go back to the vertex, down one, left one, down one, left one. So here's our V-shaped graph. All right. Example 2. When compared to the parent function f of x equals absolute value of x, which equation has been vertically stretched and shifted to the left? All right, to be vertically stretched, a must be greater than 1. So I want to look at all of my a values. I have 3/4, 3/4, 5/2, and 5/2. So I want to get rid of any answer where the a value is smaller than 1. So that means I can get rid of a and I can get rid of c. So it's got to be b or d, because 5/2 is equivalent to 2.5, and that's greater than 1. Now, the other condition is that the graph needed to shift to the left. So this is absolute value of x plus 4. This is the absolute value of x minus 4. So I want you to think about it and determine which answer you think would shift the graph to the left. Pause the video, choose your answer, and then press play when you're ready to check your answer. All right, welcome back. Hopefully you selected answer choice B. Answer choice B was vertically stretched by a factor of 5/2 and shifted to the left 4 units. All right, example 3. Avery transformed the function f of x equals absolute value of x according to the rule g of x equals -3 times f of x minus 2. Which of the following graphs correctly show this transformation? Well, the first thing I'm noticing here is there's a negative. So I know if there's a negative a value, the graph has to open down. So that's the first thing I'm noticing, which means I can get rid of answer B. All right. The other thing I'm noticing, because we have a 3, I know that it's been vertically stretched. So that allows me to get rid of A, because A was vertically compressed. So it's got to be either C or D. So the last thing that's going to help me decide is this -2. And this -2 means that the graph has been shifted down 2 units. So I want you to pause the video and select which graph you think opens down, has been vertically stretched, and has been shifted down the y-axis 2 units. Pause the video, select your answer, press play when you're ready to check your answer. All right, welcome back. Did you select answer choice C? If you did, you got this problem right. All right, now on the last example, we're going to learn how to write an equation for an absolute value function. Now, just by way of reminder, the A value is your vertical stretch or compression. The C value is your how much the graph moves left or right, and the D value tells you how much the graph moves up or down. So we're going to identify from each absolute value function the value of A, C, and D, and then we're going to use those values to write a function rule. All right, so look at problem A. To get the value of A, you're going to put a dot at the vertex, and then you're going to put a dot on the right at the next friendly point. And you're going to ask yourself, how did you move your pencil to get to that second point? So notice I'd have to go down 2 and right 1. So that means I have an A value of -2. All right. Now for your C value, start at 0, 0, and count to the right. 1, 2, 3 to the right. Because we went 3 right, that's +3. Now our D value, Notice that it did not shift up or down the y-axis, so our d value is 0. So my function rule would be y equals -2 times the absolute value of x minus 3. And then be sure to close your absolute value brackets. All right, problem B. To begin problem B, you want to put a dot at your vertex and then a dot at the next friendly point. So to get A, ask yourself, how would you have to move your pencil from the vertex to the next friendly point? Well, you'd have to go up 1 and right 2. So that is +1/2. All right. Now the next thing you want to do is you want to figure out how many did you move left or right. So if your starting point is at 0, 0, you would have to move left 2 to get to this vertex. Okay. Then you ask yourself, how many would you have to move down? Well, 1, 2, 3, 4. So down 4. So our equation would be y equals 1/2 times the absolute value of x minus -2 minus 4. Now, I want to clean that up a bit because we don't want to leave double signs in our function rule. So this would be y equals 1/2 absolute value minus -2 is the same thing as +2. So y equals 1/2 times the absolute value of x plus 2 minus 4. All right, problem C. Put a dot at your vertex, and then we'll put a dot at our next friendly point, which would be right there. All right, now ask yourself, how would you have to move your pencil to get to that second dot? Well, you'd have to go down 1 and right 1. So our A value is -1. All right, now remember your parent function had a vertex at 0, 0. So from 0, 0 to get to my new vertex, I'd have to move right 1. So C is +1, and I'd have to move up 2. So D is +2. So when I put all that together in the equation, I get y equals -1 times the absolute value of x minus 1 plus 2. All right. What I'd like you to do now is I'd like you to pause the video and try problem D, E, and F on your own. When you're ready to check your answers, press play and let's see how you did. All right, welcome back. Let's check answer D first. So the value of A on problem D was 1. The value of C was +3. The value of D was +2. The function rule was y equals absolute value of x minus 3 plus 2. All right. On problem E, the value of A was -2. The value of C was +3. The value of D was 0. So our function rule would be y equals -2 times the absolute value of x minus 3. All right, and lastly, let's check your answer on problem F. The value of A was 1/3, so 1/3. The value of C was 0. The value of D is -1. So our function rule would be y equals 1/3 times the absolute value of x and then minus 1. And that concludes today's lesson, Transformations of Absolute Value Functions.